Locating and targeting the enemy takes software. Maneuvering weapons into place and launching them, that takes castings and forgings. Among the weaknesses in the Defense Industrial Base, a shortage of people skilled in basic metalworking. Well, now a new program called Metallurgical Engineering Trades Apprentice and Learning, METAL, aims to help. Joining me with details, Justin Brooks. He's a program manager with the Composites Institute. Mr. Brooks, good to have you with us.
Good to be here, Tom.
And let's begin at the beginning. What is the essential supply base problem that the partnership we're going to discuss is actually aimed at? What's going on in metalworking as it affects the defense industrial base?
First off, metalworking in the industrial base is really important. And the program was developed in response to the shrinking defense industrial base, and we seek to create that skilled workforce to meet the growing demand in the defense sector. And this initiative offers educational pathways like apprenticeships, certificate programs, and hands-on training to get those back engaged.
But the DoD has quantified, and your program has quantified the number of tradesmen needed in this particular industry of casting and forging.
Yeah, the American metal casting sector supports approximately 490,000 jobs currently and contributes over $110 billion in economic output. The big issue with this is where we're going, though, the future. The defense industrial base will require at least 122,000 additional workers by 2028. That's really part of a broader trend across U.S. manufacturing, facing a potential shortage of 2.1 million job gap by 2030.
And basically, casting is where you pour molten metal into a shape, and forging is where you beat it into shape.
That's exactly right. All of those aspects are very important and part of that critical need for the defense sector.
Right, so the pylon on an airplane or the frame holding the engine on a tank, these are heavy metal parts that are made by castings and forgings and other techniques.
Yeah, the metal industry ensures the production of those high-strength precision components crucial for national security.
Yeah, that's, I think, something we should also point out. This is not just bending an I-beam, but it's really highly precise parts made with very carefully crafted metal materials.
Yes, and our program's really taken a broad approach, all the way from the operators up to those metallurgical engineers.
All right, and tell us about the Composites Institute. What is it, and what do you do there?
Sure. So IACME, the Composite Institute, IACME stands for the Institute for Advanced Composite Manufacturing and Innovation. And we do a lot of R&D work for the DOE, but we really got a start in our first initiative had a lot of internships. We had a lot of success with that. And then from that stemmed ACE, or America's Cutting Edge, which was focused on machine tooling and CNC machining. And we've been running that program since 2020, and we had huge success with over 10,000 participants from all 50 states engaged in online training, and we've done in-person training for over 1,900. And with that success, I believe that's why we were selected to kind of push this initiative of metal.
And before we get into the initiative, still one more question. Castings and forgings, do those tend to be produced by small businesses as suppliers to large businesses, or is there a lot of vertical integration in the tank, airplane, howitzer manufacturers that they do their own castings and forgings?
So those are often the small OEMs that are producing those and supplying our larger industries.
Right, so it's a good way for small business then to maintain a share of federal contracting if they have the manpower for defense.
Absolutely, yeah.
All right, so you have a partnership now, a multi-way, with one unit in the Defense Department and some universities around the country. Tell us about the METALS program itself.
Sure. So the METAL program, we really pushed that initiative by partnering with Penn State University to develop the online training content and that initial level 1 boot camp, or the in-person activity. And we partner with the University of Tennessee, Knoxville, to develop a workshop or a K-12 activity that we've also seen great success with.
So online means like teaching them that you have to wear your heavy leather gloves before you touch a casting or something like that, or is it more than that?
It's really more than that. We're really having this as an introductory to the industry. We go into like introductory to casting and forging, and really want to introduce people who may have never considered casting forging industry with an opportunity. So to participate in the in-person activity, you have to complete the online activity.
And when you get an apprenticeship in person and you're actually touching machinery and metal and engineering and so forth, is there a qualitative difference between the part of the castings and forgings industry that serves the aerospace and high-tech sector versus that which serves, I guess really we'd have to say automotive is pretty high-tech nowadays versus, I don't know, making dishwashers or something?
I think our goal really is to serve the entire industry. We want those individuals that go through the program to be really get excited about this industry and follow a path. So our goal is to introduce people that may have never considered it. Once they complete it, we want to introduce those to the next pathway, whether that's internships, apprenticeships, or college pathways.
We're speaking with Justin Brooks. He's a program manager with the Composites Institute. Our topic is the Metallurgical Engineering Trades Apprenticeship and Learning Program. And what is the Defense Department's involvement in all of this?
So the DoD, they provide strategic oversight for us and the funding, of course, and ensuring the program as we created it aligns with the national defense needs.
And, what part of DoD is involved with you?
IBAS, the Industrial Base Sustainment and Analysis.
Got it. And what do you sense is their big concern? And I put this in terms of the range of items that the DoD ultimately buys from the Defense Industrial Base. Small drones are really something increasingly popular, and small vessels in the ocean that are self-directed, but they're small. That's different from castings and forgings needed for a destroyer or a heavy bomber.
I think a good takeaway on that is casting and forging, they're vital for U.S. defense, with 90% of durable goods, including military equipment such as aircraft, naval vessels, and armored vehicles, are composed of casting and forging. And currently, our reliance on foreign sources for these components poses significant supply chain risk. And we're looking at those onshoring capabilities and making sure we have the workforce here to take on those new jobs.
And looking at those jobs, do they pay well? Do they have good benefits? Is it an industry that would be attractive to someone who's not interested in a psychology major at some university, but really wants to do things with his or her hands and brains and have a craft aspect to what they do? Does it pay well?
Absolutely. Those jobs they can be very lucrative, and there's so much upward momentum and mobility. For someone who comes in as an operator in the casting and forging industry, they have opportunities in quality control and process engineering, and it's more than just those early entry operators. We want to add to that metallurgical engineering background and get more of those folks into the industry as well.
Right. There's a lot of materials development that is part of this in what it is you actually cast and forge. The content of the metal is a big factor. Fair to say?
Yes. And one thing we found in our early stage research is material science has really been the new degree path. And there's been a lot of lost concern of the metallurgical engineering and the metallurgical sciences. So we really want to infuse college curriculum with more of that metallurgical.
Well, if you want to know why your car doesn't turn into a pancake nowadays when something hits it, you can thank a materials engineer.
That's exactly right.
Justin Brooks is a program manager with the Composites Institute. Thanks so much for joining me.
I'm glad to be here.
And we'll post this interview along with a link to more information about that metal program at federalnewsnetwork.com/Federal Drive. Hear the Federal Drive on demand. Subscribe wherever you get your podcasts.